Hello, this is how to use Visual Studio 2026 for Windows C++ programming. This is the wiki page for Visual Studio. This is the official website, visualstudio.microsoft.com. There's this selector where you can choose your version. There's the possibility of Visual Studio 2026 Community Edition. This is gratis, and this is more than enough for Visual C++ programming in the Windows platform. So this is what we're going to choose, free download for community. It's going to save the online installer into the downloads directory. Let's open the installer. So it's an online installer, a very small executable file that then will download from the internet increasingly larger installers and language packs and features, etc. This is how the installer wizard looks like. In here you can select whatever integrated development environments and programming language support you want. So we said that we wanted Windows style C++. That's desktop development with C++. And nothing else. The additional alternatives are Node.js, .NET desktop development, so for the Windows platform, Python, web applications, okay, there's gaming with Unity, with DirectX, cross-platform C++, including for Linux containers. So this is the only individual workload that we need, desktop development with C++. Let's now look at the individual components that have been pre-selected for us. So we will have the ATL library. We will have the Microsoft Visual C++ compiler and toolchain. We additionally have things that I have never used on Windows, such as CMake or Google Test or Boost Test. And since we're doing programming for Windows using Microsoft's first-party toolchain for C++, we also want MFC. So ATL was already selected. We've now selected MFC. We're not doing C# .NET desktop development, so we cannot use the C++ CLI toolchain, and we need a SDK for sure. And it's selected here, Windows 11 SDK. Okay, so the latest version, and then there's the previous version of Windows 11 SDK available. Okay, and you could select previous versions of the Visual C++ or MSVC, the C++ compiler, the toolchain for previous versions of Visual Studio. If you have projects, VCX, Proj files from previous versions of Visual Studio and you want to not upgrade those to Visual Studio 2026. So there's toolchains for Visual Studio 2022, 2019, 2017, and including 2015. Okay, so this would be it. Install. The Visual Studio installer has finished installing Visual Studio Community 2026 with the features that we have selected. We're not going to use a pre-release version from the insiders. And this would be a nice moment to actually restart the computer. At this moment, Visual Studio 2026 should be installed correctly. Let's run it. So from the Windows Start menu, go to the letter V, and there's Visual Studio in there. There's additional tools, but we're just going for the top level item, which is this Visual Studio. Splash screen. We're not going to use an online account if possible. So let's go skip and add accounts later. Development settings. I have my own preferences here, so I'm going to actually do those. I'm going to use Visual C++ for the keyboard layout. If it prefers dark, then that should be it. Start Visual Studio. Since we're not using an online account, hopefully we don't have GitHub Copilot chat or any other AI support. This is a welcome page for the post update. I'm going to close the GitHub Copilot chat tool window. Right click and close. I'm only using tool windows in the left part of the Visual Studio window. I usually have in here as the first tab Solution Explorer, and I'm not actually using any of these tabs, so I'm going to close Git Changes and Visual C++ Property Manager. Okay. The toolbar, the main toolbar, I like it to be extremely short. Seems to look okayish. If needed, we're going to remove some of the not needed buttons. Let's remove the navigation buttons. New project, open, add item, save all, undo, redo. I know how to press Ctrl Z, Ctrl Y. All of the debugger settings, I need them, and Ctrl Shift F, I know how to press the shortcut Ctrl Shift F for finding in files. Start window. Okay. I would wish to remove these things, but I do not know how. And this also. Okay, at this point, we have started Visual Studio 2026 for the first time. It's configured. If you restart it, it should remember all of the changes that we did. And it should start significantly faster the second time, because the first time it creates a ton of files and directories. And we should start first with the simplest Hello World C++ that's not really Windows specific. Let's see how we get there. File, new, project, solution, C++, Let's go with the console application. Okay, so we can see that it's indeed a C++ standard application. It just uses IOStream. Let's dissect a bit this application. Let's see the features of the integrated development environment. So we have line numbers, text editor, tabs at the top, and syntax highlighting, so the different colors for comments and for free functions and for include headers, etc. Let's see how we navigate to symbols. Right click, go to definition, F12. So IOStream is indeed a file. It's not a file that just includes iostream.h. The standard is interesting, Apache license version 2. Traditionally, the C++ standard include files and the Microsoft Windows C++ include files were proprietary to Microsoft, to the first party, and some parts of those files were actually contributions from other commercial entities. So it comes as a surprise to me that IOStream is actually an open source file. So Apache version 2 plus LLVM exception. So LLVM in the sense of CLang, CLang++ compilers is an open source license. Okay, let's see the other files, iStream and OStream, input and output. The same thing, the same licensing. F12 on the symbol OStream. Good. So that was go to definition. We can go to the definition of stdc out. It tells us that there's two possibilities, IOStream line 40 and IOStream line 22. I'm not sure why it says that. It's the exact same file. So this thing seems to be comment if def out and CEE is what? I know, maybe Windows C edition. Okay, so the correct definition in our case is the one at the file IOStream line 40, where it says that it's a extern C++, I know, global symbol, and of type OStream, std OStream. Decal spec DLL import. Pure app domain global doesn't do anything. And export std doesn't do anything. There's integrated development environment support for seeing what the C-style macros expand to by just hovering on top of the C macro. You can go to the definition, F12, and hopefully goes to the correct place, so the place where it's not if def out. Okay, let's see this operator F12 on it, and it goes to the correct place, which is the less than operator of cout, and cout is an O stream, and an O stream is a basic O stream. We can see which defines are active in this case, because the source code is grayed out. There's a ton of overrides for most basic C++ types. So this is an example of source code being grayed out because the C macro has C++23 is 0. Okay, so let's see if it goes to the implementation, the definition of the operator less than, but for the correct right hand side type. And it goes towards const char pointer. And this thing in this case is actually a C string literal, and it is indeed a const char pointer. Okay, let's see how the debugger works. Very simple and intuitive. You just put a breakpoint somewhere, for instance on line 7. Make sure that the current build configuration is debug. Let's actually prove that. So where are they? Choose one of these two combo boxes, the one with debug release configuration manager or x64 x86 configuration manager. Go to configuration manager, this window, and in here we can see that there are 4 solution configuration plus platforms. So there's debug for 2 CPU instruction set architectures, or whatever bitnesses of it, 32-bit and 64-bit, and the same for release. So release x86 and release x64. And our VCXProj console application 1 has also 4 possibilities with 2 platforms and 2 configurations. In this case, the platforms are Win32 and x64, not x86 and x64. Let's actually look at the files on the hard disk. Let me install a file manager that is superior, in my opinion, to File Explorer, which is Total Commander or maybe Double Commander. Let's go with Total Commander this time. So I searched on Google for Total CMD. I want the latest version, says August 19, 2025. Total Commander 11.56, 32-bit and 64-bit. We're going to try to install just the 64-bit version. So Windows 10 and 11, the versions that I have used, have always been 64-bit. Even the versions of Windows XP, SP1, were always 64-bit. So that was the year, I know, 2006. So I've always been 64-bit only, and the only processes on my computer that used to be 32-bit only were the web browsers for a while there still existed Netscape plugins and ActiveX plugins, and those were 32-bit only. But now, since the 32-bit web browser plugins have just disappeared, or I have never needed a web browser plugin for, I don't know, more than 10 years. And the web browsers on Windows are hopefully 64-bit first. There's just no need to install a file manager for 32-bit on Windows. So download page, we're going 64-bit only. It downloads it into the downloads directory. Let's install it. The download is extremely small. Don't clutter my desktop. Okay. And now we will have two possibilities. We might either run both Visual Studio and the File Manager Total Commander always elevated as administrator, or not. So always elevated or always not elevated. For now, we started Visual Studio not elevated. So we'll see if how far we can go with running both applications, Visual Studio and the Total Commander not elevated as administrator. The first moment that we're going to install issues, like, I know, the compiler refusing to do some things because Visual Studio is not elevated, we're going to switch to always use Visual Studio elevated, always start Visual Studio from Total Commander, and always run Total Commander elevated as administrator. Okay, letter T in the start menu, directory Total Commander, and then the executable. So for now, we're running it not elevated as administrator. This is a shareware. You should actually buy the license. Let's configure it. No button bars. No function keys. Operation left mouse button. Display show hidden and system files. And we're going to need a real text editor, not Notepad, something way better. Quick search, letters only. Okay, at this point, I'm going to install a way better text editor than Notepad. People usually go with Notepad++ or Visual Studio Code. So I'm not going to go with those. I'm going to go with the KD kit. This guy. Get it. For Windows, nightly installer. And there's also a nightly 7-zip, which is what I'm going to prefer. And I'm going to have a number of directories in my C:\, drive. First of all, C:\temp, and then C:\temp/bin. This is not an installer, it's just an archive, and we're going to extract it. I'm not sure if we have 7-zip yet. We totally should. It's a development machine, Windows 11 Pro. So we totally need 7-zip. Windows 64-bit download, very small download. This is actually an installer. I don't mind having 7-zip installed and appearing in Windows and remove programs. Even more, I want it to be that way because I want to be able to have Windows Explorer, File Manager, Context Menu actions. So I want this sub-menu 7-zip where I right-click on a file or directory or archive. Since we're at must-have applications on a Windows development machine, I'm also going to go with WinMerge. Or difference viewer. I also want to install this thing, not just download and extract it. So I want the 64-bit setup exe, the default option. SourceForge.net. It picks a mirror, starts downloading. Open source software. No 32-bit, nothing. And this is the most important setting, enable Explorer context menu integration, which is enabled by default. And that should be it. Let's launch it first and see if we need some configuration. Seems to look okay. Let's see how WinMerge works. We have two files, we select them and then right-click and WinMerge. The menu is not here yet, so let's see if we can do something. I have started WinMerge application, and from the main menu, Edit, Options, choose the tab Shell Integration, and we want Add to Context menu. Register shell extension. And now we have it here. Maybe it was before and I didn't see it. So it's under the antivirus Microsoft Defender. It's just two files which are binary with 4ccmz. So they're Windows native binary files. There's nothing to compare. But this is how it looks like. Okay. Next up, we have a text editor. We should configure the Total Commander file manager to use our preferred text editor when we press the F4 key on the keyboard on top of a file. So C:\10 bin. In here, there should be the Kate executable. Temp bin. So we have the text editor Kate as a 7-zip archive. Let's extract it. Okay. We have this directory with a very huge name, and it's okay because it tells us the version 10755, and the executable is the one with extension exe. So this guy. We're inside Total Commander, so from the main menu, configuration, options, operation, edit, editor, browse, and it selects automatically the current directory and selects automatically the filter.exe. So it's easy for us to just select Kate from there. Okay. Let's actually start creating a structure of directories for the files that we're working on and we're developing. So c:\temp/daily. No, should be a work in here. With today's year, today's quarter, today's date. Make a subdirectory and have this Visual Studio solution in there. Let's copy the directory name. File, in Visual Studio close solution. File, new project, and select the same thing. So C++ console application says prints hello world by default. Next, select our directory ending with 1 and create. Okay, so let's look at the most simple Visual C++ solution and project. This is the directory that contains everything. It's called console application 1. It's similar to this place in the Solution Explorer in Visual Studio. And then inside there's a file with extension slnx, which looks like this. Says that there are two platforms, x64 and x86, and that inside this solution, slnx, there's one C++ project because we can see the extension vcx_proj with the name console application 1, which will correspond to this node, the second node in the Solution Explorer tool window in Visual Studio, and to this directory. Okay, so we have the project and we have just one file, this thing. Everything else is temporary files and should not be put on version control. So what should be put on version control? This directory, console application, this file, console application 1 slnx, this subdirectory, console application 1. You should not put on version control the hidden subdirectory .vs. And then you should not put on version control the file ending with user, this thing. Filters, yeah, you probably want it because that makes the separation, that makes these two subdirectories, the source files, resource files, and header files. And that's defined in here, says that if a file extension is cpp, then it should be put under here. If the file extension is .h, it should be put under header files. If the file extension is rc, then it should be put under the Solution Explorer node resource files. Let's actually prove that some files should not make it to Git version control by actually putting this solution under version control. I have searched on Google gitignore Visual Studio. I want the .gitignore file that's been maintained by the community from GitHub gitignore. This file changes several times per year, should be up to date. Let's go to the raw version and save it locally. File save page as, Ctrl V. console application 1, and the file name should be .gitignore. Let's see if the file is saved correctly. It usually is not. Okay, so wrong name. Shift F6 to rename, should be .gitignore, not gitignore.txt. Let's see how the file looks like. We have pressed the F4 key the first time on top of a file. This should open the viewer, which is kdcate. This text editor is starting for the first time. It's doing some maintenance. Okay, let's see if second time it starts significantly faster. So F4, and it does. So these are the files that are usually created by different versions of Visual Studio. And traditionally, Visual Studio was not created for Git and didn't have the idea to have all of the files that clutter the Git working directory in a single hidden directory top level. There's a ton of subdirectories there: debug, release, bin, obj, x86, x64, etc. that are not part of the top level .vs directory. So this is an issue. Everything in time should be moved to a single directory, top level. If it's named .vs, then that's okay. But random files splattered all over the place like this, console application 1.vx vcxproc.user, should not be. The intermediate build files should not be placed in the same place where your Git clone is placed. Okay, all sorts of files for various programming languages that are supported by Visual Studio, by various main commonly used popular Visual Studio extensions, plugins, etc. Okay, so I like what's inside this file. And at this point, we should actually install Git. So let me install it the way I do it. Git, Windows, portable x64, c:/10/bin directory. In the left half of the screen of the window for Total Commander. So Total Commander is a twin pane orthodox file manager, has a left pane and a right pane. In the left pane, I will have one of the tabs dedicated to the c:/temp directory, usually the second tab. So it's easy for me to navigate to directories because I'm not actually navigating, I'm just changing directory. I'm just switching between the tabs in Total Commander. I always have my work, which is a directory with source code, in the right pane in the first tab. Okay, so this is portable Git. It's a 7-zip archive, but it's a self-extractor, so it's a Windows standard ELF executable, the standard portable executable. So double click on it. The self-extractor starts, but you could also extract it with 7-zip. It says in the name that it's actually a 7-zip archive. So you could also go right click and 7-zip and extract. Okay, there's nothing to configure because there's no installer wizard for Git for Windows in this version, portable Git 7zip.exe. which means that we don't really know what are the settings for Git for auto changing the end of line characters. It might change those when on Windows, it might not. So it's important for us to actually tell Git that this entire directory, the solution folder, the Git work directory, should be excluded from changing the end of line characters. And we do that with a .git attributes file. The content that we want looks like this, so says any file type with any file extension should not be a text file, but a binary file. So Git, when sees any file of any type with any extension, should not think that it's a plain text file and that it's okay to change the end of line characters from \n to \r\n and back just because it's Windows. So it doesn't matter the platform, doesn't matter the file extension, Git should just never ever change the end of line characters. We know what we're doing, we're grown-up people. We tell Visual Studio what end of line extensions to use, and that should be used across the entire team that uses this project. Okay, next up, we want to create a .git directory here, so to put this directory under version control. Let's see how we do that. There's multiple ways to go. One of the ways is to just start this executable. So :\ten\bin/portable git -git /git -cmd.exe. And we go git init in here. Okay. At this point, we can look at the version control. So in the work directory, I go Control down arrow key. It goes to the command line in Total Commander. And in here, we have the history of the commands that we have run in here, with the newest command that we have run being the first in the combo box list. So just Control down and press Enter. We'll always go to the last command that we have run in the Total Commander command line. Okay, let's look a bit at the Git repository. This is Git GUI. It's a first-party application from the Git project. It becomes part of the Git installer for Windows. It's from the Git project. It uses a cross-platform graphical user interface toolkit that's called TCL-TK, this guy. Works even on Linux desktop or on Windows or on macOS desktop. This is the application that I always use because I use both Windows and Linux a lot. As I said, some of the files that are created by Visual Studio by default should not be under version control. And I said that the top level directory .vs should not be under version control, and you can see that it's not. It's git ignored. Where? So .vs. In here says Visual Studio 2015 or newer, should say, so this is an issue. Hidden directory vs. So this is also wrong. So these comments should say Visual Studio greater than or equals to 2015 top level hidden directory. It's a directory because it has slash at the end of the file, and it's the name of the directory .vs. Next up, the file console application1.vcxproc.user should be git ignored, and it is. It's not going to be added to the first initial git commit. And that's git ignored in the same file .gitignore that we did from GitHub, somewhere in here. Not having a search is not the best thing ever. So let's we want to search inside the gitignore file for files with extension .user. So it's the third type of files that are git ignored. The rest of the lines in here are comments. So any file with extension .user should be just git ignored. Okay, so we do the first initial git commit, .git ignore, .git attributes. These two things, I always have them in all of my projects. And then whatever Visual Studio wizard to create a project solution has created. So the slnx file, the vcxproc file, the filters file, and the actual C++ source code file console application1.cpp. The git commit message for the initial git commit has the same title always. Initial commit. And now Visual Studio, and now Git complains that I haven't yet specified neither my email address or my username. So let me do these two. So in the text editor, I'm creating a new file. This looks like a Win32 API message box. And that type of Windows has this Easter egg where you can go Ctrl+C to select the entirety of the text on the form. So the title, the body, and the buttons. Ctrl+V looks like this. So this is the buttons, this is the title, and this is the body. So we need inside Git to run these two commands. Email address, paste anyway. And now we can try to commit again. And this time the commit was successful. We can look at the history in Git GUI application, main menu, repository, visualize all branch history. There should be just one branch, Git branch, local one, named master, just one Git commit with the content that we expected. So Git commit text and title. These are the files that are being changed. In this case, all of these files are being added. It says new file. Okay, it complains that I do not have trailing new lines. And I like to have trailing new lines on files, but then files created by Visual Studio sometimes do not have these. Visual Studio does two types of files, the ones that are generated by something similar to the scaffolder. So when you go file new project or file new file or file new class, so using the wizard in Visual Studio, that will use some scaffolding technology, some templating technology. But then when you go and create a file, edit it, and then you tell Visual Studio to format the file, the Visual Studio will actually use the settings that you have in Visual Studio for formatting that file if you tell Visual Studio to format a file. Whereas the files that are created by Visual Studio might not be formatted by Visual Studio. So the templates that exist in Visual Studio create the files in a certain way, for instance, using tabs instead of 4 spaces for indentation, maybe not having a trailing new line, maybe having the wrong end of line terminator. And Visual Studio will just not format those, even though Visual Studio does know how to format files because you instruct it to. So 2 different files created by Visual Studio. Some might obey the Visual Studio coding guidelines and some not. Okay, so we got to the point where we have installed Visual Studio 2026 with the desktop Windows C++ toolchain. We have created the minimal possible C++ standard console hello world text application. We managed to build that application, we managed to debug that application, and we managed to put that the source code of the application under version control using Git. Okay, at this point we have proved that Visual Studio works correctly. Next up is to create incrementally more complicated C++ applications for the Windows platform. So this is a cross-platform application what we have right now. So let's make it not cross-platform and Windows specific. File, close solution. Let's create a new directory in here named 2. Copy the directory full path. File, new project solution. And let's create a application that is console but is Windows operating system specific. Let's see how we go there. This thing, Windows Desktop Wizard. Create your own Windows app using a wizard. Next. Control V. Project 1 sounds okay. Create. And this is the wizard that selects what type of project and solution should be generated by Visual Studio. We can choose between a DLL static library desktop application with graphical user interface or just console application at the command line. We keep the default selection, which is console application, and we can increase the complexity by using a precompiled header and MFC, just like that. Okay. So let's see what is the source code that's being generated. There's a .h file named pch.h. This is a precompiled header. Previously this file has been called stdafx.h, and now it's called pch.h. This file in this case is just including another .h file named framework, f12. I'm not sure why I didn't synchronize the text editor with the Solution Explorer. There's a button for that in the tool bar of Solution Explorer tool window, this button sync with active document control open square parenthesis S. Okay, let's see what it does. What did stdafx do previously? It included Windows. It included Windows and it defined some defines such that the vast majority of Windows.h was actually not included. So include lean and mean, extra lean, whatever. Some define that exists in the windows.h file. SDK. So this is the Windows 11 SDK. In our project, there's a target var.h file, and that's going to include the correct version of Windows 11 SDK because of the settings inside the VCX Pro, so the settings of the project in here. Okay, so things have grown more complicated in the last 20 years. The file that we're interested in, the entry point of the application, is the one that contains the main function, project1.cpp. But then this is served by a .rc file, which is a Windows, Microsoft, C++ resource file, source code file. So a file with extension RC that gets compiled to binary resources that are then going to be inserted into the final .dll or .exe file or something else, .ocx, etc. In this case, the resource file, project1.rc, contains just one thing, a table of strings, which might be useful for, I don't know, translation, or translating the application title from project one to something else. In the future, if you want to translate from English to, let's say, to German. Okay. And it's using not const char pointer C style string literals, but Windows style UCS to UTF-16 little endian WCHAR T, tchar const pointer. Let's see what this L does. F12. It goes to the way wrong place. But we can see from the expansion, when we hover on top of the string literal, it says that it's a const char pointer, not a, it's a const wchar t pointer, not a const char pointer. Okay, L always means wide. And then Microsoft also has an underscore uppercase T, which will pivot and be either L if the Unicode environment, if the Unicode C macro is defined with all uppercase, or to const char pointer if it's not defined. Let's go a bit to the properties of the project. And let's look at the defines. Where do we have those? So Unicode with all uppercase C define is defined. Unicode all uppercase with a underscore prefix is defined. And also we have defines for debug, meaning that we want, when we compile the source code, to not use optimizations. The define for the Windows subsystem console. This one. So under the VCXProj properties, project one properties, linker, all options, and subsystem, it says that it's the console subsystem. The other actual possibility is Windows subsystem. So on Windows, when you create an executable, that executable is usually either console subsystem or Windows subsystem, whereas on Linux, there's no such thing. An executable is just an executable. So the difference between these two is how they handle opening an additional terminal emulator window when you start the executable. So on Linux, if you start a executable from the start menu, it's not going to open an additional terminal emulator. If you want to run an executable inside the terminal emulator, first you start the terminal emulator. I don't know what you're using, console or GNOME terminal, and then from there you start the executable. But then Windows has a feature for its users, a nice to have features when you're opening a, for instance, text user interface executable, something similar to Norton Commander or Midnight Commander. It will open the executable, but it will also open the terminal emulator, so cmd.exe or Windows Terminal. And it also will open the something similar to bash, so cmd.exe, the text shell interpreter. Such that you can see the text user interface. Otherwise, you would not be able to see it. Okay, so long story short, if you want standard input, standard output, standard error, and you're doing a text user interface application or a console application, you should make sure that you're using subsystem console. If you have a graphical user interface application with Windows, with main menus, etc., and do not want to see useless terminal emulators, then switch to the subsystem Windows. Okay, let's see what else do we have in here. So we have a .rc file. We have a C++ file. The precompiled header has include a .h file and a translation unit, pch.cpp. Previously it was called stdafx.cpp and stdafx.pch. And the pch.h is split across a number of files. There's framework.h, there's targetvar.h, and then the files which are not related to the standard, the precompiled header. So the files related to precompiled header pch.cpp, targetvar.h, pch.h, framework.h. The rest of the files start from the translation unit project1.cpp, which includes project1.h, which then includes resource.h. Unfortunately, on Windows, the file systems are case insensitive. So it's the same thing if you say resource.h with an uppercase R or resource.h with a lowercase r. So this is a bug in my opinion. These things should not be allowed. Name the file always the same thing, always lowercase or Pascal case, but not in different ways in different places. Let's look a bit at the differences between the configurations. So there's the two platforms that are pretty easy to understand. There's Win32 and x64, x64 and x86. So this means that if you're choosing the solution platform x86, the generated executable in this case will be 32-bit, and that runs correctly on Windows 64-bit because Windows can run correctly. Windows 64-bit can run correctly Windows 32-bit executables because there's Windows on Windows 6432 subsystem that handles everything correctly. Okay, but you might want to generate Windows x86 64-bit binaries or 32-bit binaries. How you decide is about the actual customers that you're deploying your software to. If they use new enough computers, they have very little chance of having Windows 32-bit only. So you're probably going to create software that only runs on the supported versions of Windows, the versions that are not end-of-life and are still supported by Microsoft. And that means probably Windows Server 2016 or newer, and Windows 10, but only the newest versions and newer, and Windows 11. And I'm not sure if all older versions of Windows 11 are still supported by Microsoft. So if that's your goal, to only support the versions of Windows that are still supported by Microsoft, then you probably all of your customers are using Windows 64-bit. If that's the case, then you can just build all of your software, including your installers, be 64-bit. If you still have users that you want to sell your software to and they run 32-bit software, then 32-bit Windows, then you might either provide a 32-bit installer that only contains 32-bit files and only sell that. That will run correctly on Windows 32-bit and also on Windows 64-bit. Or you might want to provide an installer that's 32-bit, so it works on both types of Windowses, 32-bit and 64-bit. But then the installer will install two sets of files, 64-bit only files and 32-bit only files. And the switching you can do, for instance, inside the installer. If the operating system is 64-bit, only install the 64-bit files. Or you might have other mechanisms. You could install both sets of files, 64-bit and 32-bit files, and then somehow switch between these files. Maybe you have directories with symlinks, maybe you have, I don't know, a C# executable that's any CPU that will pivot correctly between 64 and 32-bit, and it will load the correct Visual C++ compiled DLLs depending on if the Windows is 32-bit or 64-bit. So let's suppose that all of our customers are 64-bit. Therefore, we're going to just never use the solution platform x86. And first of all, we're just going to destroy that thing. Let's see the steps. So from Visual Studio main toolbar, combo box with x64, configuration manager, active solution platform combo box, edit, select x86, so the 32-bit one, and delete it. Let's see if this checkbox actually works. Remove deleted platforms from all projects where it is unused. Okay, so at least the platform for the solution has been removed, but we also need to remove the platform from all of the projects. So for the project 1, column platform, in this cell, there's a combo box. Go to edit, select Win32, remove, yes, close. So there's no need to have clutter in your Visual Studio configurations and platforms. Make sure you clean them up correctly, because other developers in your team might not know which one is the one that we're actually using. If you can have just debug and release as solution configurations and only one thing at the solution platform, then that's what you should go for. Close. So we can rebuild the solution. Right click in Solution Explorer, rebuild solution. At the bottom tool window, we can see the output. So it says output from build, there's nothing. I'm not sure how that's possible. Okay, it only now started. Okay, so there's two translation units. This guy, pch.cpp, project1.cpp, and then there's a linker step where it takes the generated intermediate binaries for the two translation units and combines them into project1.exe, and not only. Let's look a bit. So this project1 is inside the directory 2. There's a project1 directory. There's a x64 subdirectory, a debug subdirectory, and in there we have the intermediate files. Let's see where the output is actually put. So configuration properties, CC++ output files. So the PDB file is in the intermediate directory, VC platform toolset version PDB. Wow. Okay, so the final files created by the linker are actually inside the directory of the solution, not the directory of the project. Then the platform, which is x64, and then the configuration, the Visual Studio solution configuration, which is debug, and then the two files. There's project1.exe, which is the executable, portable executable Windows native 64-bit executable that is dynamically linked, depends on a ton of Win32 API DLLs. And then the debug symbols are not inside the .exe file, but are in a separate file, the file with the same name, so project1, and the extension pdb, which is, I know, product database, program database. This is needed for debugging. Because we're in the debug configuration, some things are different in the debug configuration versus the release configuration. When you're you should always use the release configuration when building the final files that you're shipping to customers, because these files are faster, smaller, are being optimized. The execution is going to be optimized by the C++ compiler, but also you're going to be able to ship this file because the file will depend on the Visual C++ 2026 redistributable, and that's redistributable just if you build using the release build configuration. The Microsoft Visual C++ redist is not, you are not licensed to ship it to your users if you build with the debug configuration, build configuration. So make sure you always use release when you're building your installer file and then you're shipping your file to your end users. So the difference between debug and release is the type of Visual C++ redistributable that you're using. The fact that there's additional debug support inside the debug configuration, so debugging for support for allocation for free, for detecting issues with allocating and freeing, such as double free, writing outside the bounds, and other things. Part of this implementation is visible to the developer on these three lines, 8, 9, and 10, where the C++ new keyword is being replaced with this thing, debug new. Okay. We can see that debug new doesn't do anything. It's grayed out because we're not in the debug build configuration. And that means underscore uppercase debug is, see, macro is not defined. Okay, you change the Visual C++ configuration, you wait a bit for Visual Studio to refresh, and now you can see that debug new is defined and is new with two parameters, file name and line number. Okay. The C++ source code uses const wchart pointer. So it uses UCS to UTF-16 little endian window style, which means that each character is stored not on 8-bit, not on a byte, but on 16-bit, so on 2 bytes. In this case, for English US characters, the character F is similar to the 8-bit character uppercase F, but then there's an 8-bit of just zeros, such that the entire 16 bits are being used. Okay, so that's an uppercase F, and then the byte uppercase F, and then the byte 0, and then the byte lowercase a, and then the byte 0, etc. And for that, you need to pay attention in various places. You need to make sure that you're using uppercase L to switch from const char pointer to const w char t pointer. You need functions that can handle such a type, such as wprintf instead of printf. So printf uses const w char t pointer. Okay. And then get command line is a Windows 32 API function. And it's actually 3 Win32 API functions. There's a get command line A, which is a function exported from a DLL. There's a get command line W, which is a function exported from a DLL. And then there's a get command line, which in this case is a define which switches between get command line W and get command line A, depending if you have the C define all uppercase Unicode defined. And we do, because we have just seen that thing. So I click on the project properties and then C++ and command line. And we can see that it's defined in here. /D and then Unicode between double quotes. Okay, and then all of the functions that can return string buffers, so char pointer, all of the functions that take input parameter of type literal string, so const char pointer, needs to be modified to support, in this case, at least wchart, such as this guy, afx win init. Okay, afx win init is defined in a .h file, which means it will respect our C preprocessor, our defines. And in there, there's a parameter of type lpt_str. So T is a Windows thing, which is a C macro and will pivot depending on the Unicode define to either, so let's see what it says. So it's an str, which means string. It's a T, which means it will pivot between, switch between char pointer and w char t pointer. And LP means long pointer. So this is a non-const, but still an in. Null terminated w char t. Because Unicode is defined. So some DLLs export two symbols, one with postfix, suffix uppercase A, another one with suffix W, and then the headers will switch between those depending if the Unicode define is defined. And then for some others, where there's no DLL, the source code is inline, just in include only. There you can define just one function, and depending if the Unicode define is defined or not, the generated code will be different. We'll either use char pointer or W char T pointer. Okay, so this one respects the Unicode define, this one respects the Unicode define, this one doesn't respect the Unicode define, but it's always W char T pointer, always W char T pointer, and the rest of the symbols don't handle strings at all. Like this one, it's int, this returns an int, this is an H module, whatever that thing is. I don't know what this thing is. Okay, so when you work with strings in Windows applications, Windows only applications or not cross-platform applications, and you're using Win32 API, or you're using MFC, you're using a TL, you're using the Visual C++ resources and precompiled headers, etc. Always think about your string type. You need to choose either you're only ever using WCHART, or you're always defining the Unicode environment variable, and then you're using the functions which switch between the W and A function, or you always use the functions that end with W. Windows 11 is from the line of Windows NT operating systems, and the native string type here is this guy, WCHART pointer. So WCHART meaning 16 bits, 2 bytes. And you're better off with always using this type if you're interfacing a ton with the Windows operating system, with the Win32 API. So that's one way of going, because you want your software to work correctly on different languages. You want it to work correctly on if it's translated to Japanese or to Vietnamese or to Arabic. So you want to support all of the possible characters that can be supported by strings. And you also want, of course, you want the newest, latest, and greatest color emojis. So you should always not use ASCII only strings. So make sure you're using the strings that you're using can support every possible Unicode character. But how you go about doing that, there's just two possible ways which are recommended, which is either use Windows style WCHART always, or always use char pointer UTF-8, so Linux style, and then only when interfacing with Win32 APIs, maybe create a anti-corruption layer, a very minimal wrapper on top of the Windows API, such that you switch at the very last moment from char pointer UTF-8 to WCHART pointer. So the second way of working is called UTF-8 everywhere. I searched on Google for UTF-8 everywhere, and the website is utf8everywhere.org. And it's all about Windows. So yes, you want your application to be translatable to various languages, which means you're not only going to use ASCII characters, you're not only going to use ANSI characters, and you're also not going to use a very specific to a language encodings. You're not going to use, I know, big J, Shift S, whatever, the Windows code pages. So you just select between these two when you're on Windows. Either char pointer UTF-8 everywhere, like said in this manifesto, or UCS2 style WCRT pointer everywhere. If you have some of the source code char pointer UTF-8 and some UTF-16 WCRT, do make the split extremely evident, put them in totally different directories, create two different DLLs, etc. And pay a ton of attention between traversing these two different worlds. If you're going to use open source libraries that work correctly on Windows, such as, I know, curl or Apache, portable runtime, NSPR, the crypto libraries from Linux, etc., all of those are probably going to be char pointer UTF-8 only. And if large portions of the source code that you write and your organization writes is UTF-16 UCS to WCRT pointer only, then again, there's a place to create very strict barriers and boundaries between these two different worlds with anti-corruption layers and very small wrappers that just convert the string encoding from one to another. Let's look a second more at this example. So this example doesn't return early, it returns just once at the end. This is the way I actually program, so I don't return here and here where the errors happen. It uses exit status. So when main returns, it will return an int, and that int will be the exit status of the process. 0 means success, anything else is an error. You could have positive or negative exit statuses, and in this case there's just one exit status, which is 1, which is either AFX win init failed or get module handle failed. Okay, as you can see, it does printf, which means writing to the standard output, and we're Windows subsystem console, so we can do that. The standard output will be seen by the user because the application either is started from a terminal and then the user can see the terminal, or if you double click on the application will actually start a terminal just to be hosted somewhere. Let's see how that happens. So we find the executable, and if we double click on it, something happened. It opened a cmd.exe, showed us something like nothing, because in the best case scenario the application doesn't do anything, and then it finished. Okay, but it doesn't use standard error, which might or not be the case for writing fatal errors that actually crash the application or return early the application. Okay, the source code doesn't use std::. It uses using namespace std, which I don't do. I always go std::. but then there's no symbol from STD used in here. So it's just support for future expansion. Also, there's this global, the app. Let's see what the app is. CWin app is a Win thread. So it's part from ATL MFC. When we have created the application, we have enabled the checkboxes to have the application be MFC. EFX Win. So EFX Win is not ATL, it's actually MFC. So this is a MFC class, one of the two big libraries that we're using when we're writing applications in C++ for Windows, one being ATL, the other one being MFC. So two libraries of for programming in C++. There's a ton of support in here. There's C++ string types defined as part of MFC, the type C string with uppercase C, uppercase S, that has 1,000 methods and other niceties. It's an object-oriented framework that you can use to create Windows applications with graphical user interface or not. Okay, so that's really about it. Next up, we should increment and go to a simple Windows application that uses the graphical user interface. So has a window. Save all, close solution, and create the third directory. We're also going to use the wizard. You can go right click in the Solution Explorer and create new solution, but apparently we cannot any longer. File, new project, C++. You can select Windows in here, it doesn't really matter. Project types. Desktop. Let's see what happens. Windows Desktop Wizard and Windows Desktop Application and MFC apps. Wow. And ATL. Okay, let's look through most of these. So Windows Desktop Wizard is what we have used before. It asks if you want just a console application or if you want a desktop application. Let's create a desktop one. We're still going to select precompiled header, not going to select an empty project. Okay. Let's run it and see what this thing is. Okay, so it's a graphical user interface application, has a window, has a main menu, has a help about menu with a message box, file exit menu. I don't use the diagnostic tool, so I'm going to close them. And let's dissect this application. It's also a minimal application, but for Win32. It's mostly C programming language and with some C++ programming language. So let's see what's where. So pch.cpp, pch.h, framework.h, and target.var.h. All of these are part of the precompiled header. You can look at precompiled headers, you rarely interact with precompiled headers. That's the whole purpose of a precompiled header. You're just putting there the way you're including the Windows headers and maybe some com includes, and that's it. All of the rest of the things you're doing in non-precompiled header files. Let's look a bit at the precompiled header. Previously, other files were used because we had a command line executable. Now we're having a graphical user interface application, and now we can immediately see the biggest include file of all, windows.h. So usually when you create user space Windows applications, you're using windows.h directly, not the individual files that are being included in windows.h. And in order to make compiling types way better, you're excluding some of the functionality that's not that often used by using one of the defines in here, such as win32 lean and mean. Which is defined. So first you define win32 lean and mean, and then immediately you include windows.h. Okay, tchar is for support for _t. We'll see if that's actually used. Okay, I do not know what these three things do. Go to project1.cpp. We can collapse all of the symbols, so Ctrl-M-O. Doesn't work any longer. Let's make Ctrl-M-O work again. Let's see if we can do that. So from Visual Studio main menu, Tools, Options, search for keyboard. Says that there's a keyboard configuration window. It's the same thing that existed on Visual C++ 6. Not really. And in here should be collapse to symbol. Collapse all. And it's still there. So edit collapse to definitions with the wrong lowercase t. And it's Ctrl-M-O. And maybe Ctrl-M-O is also defined for something else. Yeah, maybe I pressed the wrong key combination or something. Ctrl-M, where are you? Ctrl-M-O. Okay, so what it does, it takes the current text editor in the tab that we are. Where are you? And collapses to top level definitions. Not really. Collapses to definitions. Just shows you the definitions of symbols, not the implementation, the bodies of the free functions and methods. Let's see what we have in here. So we have a free function win main and 4 more functions. There's forward declarations and the bodies of the functions. Okay. The entry point is this guy, win main. Let's actually see if that's the case. Probably in linker, command line. I'm not sure where it's defined that win main is the entry point that we can actually control. there might be some intermediates between the actual entry point of the executable and W in main, either in MFC or in Win32, or in the fact that the project 1 is Windows subsystem Windows, not console. But still, this is one of the first places where we can control execution, except for things that are being run before, because this is a C++ code base, so you might have some code running before W in main. We can put a breakpoint at the very first point where we can put a breakpoint, which is line 25, the opening bracket of W in main. Let's start the debugger. Diagnostic tools has reappeared. Let's close it again. And the debugger worked again okay without us actually configuring anything. We just clicked once on the gutter in here on line 25, and then we clicked on the main toolbar on the button to start the debugging. I don't really use this toolbar. Let's see how we can remove it. Text editor. Okay, the rest are kind of must-have. Okay, so we're using debug build configuration. Our reference parameter is just for the compiler to not issue warnings, right? Probably. That's why it went to line 32 immediately. Let's actually figure out what our reference parameter is. So it's square parentheses hprev instance semicolon. Oh, what does that do? I don't know. Okay. And then being a Windows application, Win32, it tries its best to be Unicode in the Unicode only, so not have ASCII code, ANSI code, and Unicode in the Windows style, so WHRT pointer. It's using straight load string W, so straight Win32 API functions from the Win32 DLLs, which are exported with the W suffix. So it's not using any intermediates such as load string, and then that will pivot between load string W and the load string A, depending on if the C macro Unicode is defined or not. Okay. My register class doesn't handle strings. H instance is, I'm not sure what, maybe a pointer, just a pointer. So H init instance only handles a pointer, an integer, and a int. So it doesn't need to be WHRT specific. And it's defined in our source code. Okay, WHRT specific in here. Show window doesn't do strings, so doesn't need a W prefix. Update window doesn't do strings, so it doesn't need a W prefix. Postfix, whatever, suffix. So all of the Win32 API functions exported from Windows DLLs that don't have strings as return type or input parameters do not need to export one with suffix A and one with suffix uppercase W. Okay, this is about callback. And dialog. Oh. Raw painting, implementing Windows main loop messages, events, the Windows main loop message queue, send message, post message, pick message, those things. Some of the possible values that can be sent through the Windows graphical user interface main loop. Set focus, enable, change the text, read the text, paint event, close the window, show the window, change the cursor on top of the window, change the font of the window. So labels are windows in Windows Win32 API graphical user interface. So when you can tell a window, please change your font, because that window might be actually a label. And WinVer is the Windows version. The Win32 API was created when Windows 32 started to appear, which is Windows 95, and is an evolution of Win16 API, which was used for Windows 3.11 for workgroups and other Windows versions before Windows 95. Windows NT4 was also 32-bit from the same time, from I know, maybe 1994, and Windows 95 from 1995. Okay, and this is the define. So these symbols have existed in Windows 95 and Windows NT and newer. Win32 API tries to be as backwards compatible as possible. So it's extendable, not removable. You can add symbols, you cannot remove symbols. Symbols being exported functions from DLLs, and also symbols which are used for programming. So the symbols declared in C++ header files, for instance. The goal here is to make executables that worked on Windows 95 continue to work correctly on Windows XP and Windows 11. Because those were 32-bit, used Windows 32, Win32 API, there's no reason why they should not run correctly on Windows 11. If they're not doing very complicated, low-level stuff, like working with specific hardware or with specific Windows kernel modules, or depend on, I don't know, CPU timing or stuff like that. If they're just well-behaved, simple, standard Win32 API, they should work correctly without any recompilation. The executable that was created in Windows in 1996 for Windows 95 should still run in this year in Windows 11, even though the CPU architecture has changed from 586 Intel to AMD 64, from 32-bit to 64-bit. Okay, and using WinVer, they define the generation of APIs, so the functions exported by DLLs and the symbols defined in .h files. Such, for instance, that you can create, even in Windows 11, you can say, let my application be able to run on Windows XP, not on just Windows 11. And for that, you're restricting your WinVert, make it lower. And that will hide a ton of the symbols that were added, for instance, in Windows Vista or Windows 7. Yeah, so most of what we see here is C programming language, not C++, and it's raw handling of Windows graphical user interface main loop with a ton of messages, looking through the message pump. This is the message pump, get message, translate accelerator, dispatch message, translate message. There's callbacks for the main loop. Show window is actually calling the Windows main loop with that symbol that we showed previously, SW show and SW hide. It's the function show window is the body of the function seems to be part of the Windows DLLs, and just the definition of the function is part of the windows.h files. So we cannot see what's inside the body of the function, but it's something like, depending on what's on the second parameter, and cmd show might call send message or post message sw hide or sw show, as we saw previously in that list of integers that can be passed through the main graphical user interface main loop. There's icons and cursors. Okay, in here where it says WM paint. So this is a integer that's being passed through to the through the graphical user interface main loop. And it has existed for always. WM paint certainly existed in the very first versions of the Win32 API, and also on Win16 API, because it's a very, very basic building block, being able to control all of the pixels that are being painted on your window. Window being an actual window, or a more complicated graphical user interface control, such as a label or a text box, a rich text format, or a web browser. Everything is a window, accepting controls which are complicated and then do their own painting without actually having windows inside. Think aliens in Linux. Okay, and then there's low word and high word, which does bit operations. There's a ton of structs. So everything, the Win32 API is not a C++ API, is a C API. So for the C programming language, and that makes perfect sense because it uses dynamic linking. So it's similar to the rest of the graphical user interface DLLs that exist in Windows and the rest of the Win32 API windows. They work in all programming languages. They're very bindable. That's the definition of dynamic linking plus the C programming language, is that you can create wrappers or on top of that for all programming languages, and all programming languages have native or semi-native or a very simple way of interacting with C-only DLLs. In C# there's pinvoke. In Java there's GNI and JNA and Genie and other things. On C++, you're just including the C header and everything will just work because C++ is the C programming language plus some extras. And all of the other modern programming languages, all of the possible programming languages that have ever run on Windows and want to interact with Windows COM and Windows API have supported interacting with C-only DLLs forever. So CDLLs means load library, being able to find symbols that are exported from a DLL, so procedures, functions, being able to get a pointer to that function, being able to call that function, calling conventions, std call, cdecal, fast call, etc. For instance, this callback thing is std call. There's also fast call, Pascal call, and then knowing the various, having wrappers over the various parameter types, knowing how to pass parameters via stack and everything else, how to return from a function, how to pass the return value of the function, so the calling convention. And then maybe the most complicated thing, knowing row pointers and callbacks. Okay, so that's about it. Let's look one last time over graphical user interface applications in Windows. In this case, using not even using MFC, so just raw Win32. This is how the application looks like. In Visual Studio, there's tools to inspect running Win32 applications from the Visual Studio main menu tools, and then Spy++. Yes, so this elevates as administrator. And then in the right bottom quarter, we have the graphical user interface application. In the bottom left quarter, we have Spy++, the application from Visual Studio. And we're going to see all of the windows on the desktop of the current user, on the current desktop. There's a parent-child relationship. Top level is the desktop that has various children. Some of the things you can recognize from the Windows taskbar. Others are just not important windows, but which don't have any parent, and they get reparented automatically to the desktop. So there's a quick settings control center, there's an input method entry, or a ton of things that exist in here somewhere, but you don't immediately get to see them. There's a Chrome shell. Okay, it's really hard to know how to expand these nodes in order to get to project one. So the fastest way to do it is to actually use the search tool. So these binoculars, and then Finder tool, grab this cross arrow and put it on top of the window and press OK. This Spy++ window is MDI, multiple document interface. So we want to make sure that we see all of the child window, Windows 1, which means we should maximize it by double clicking on the title window. So there's this window, Microsoft Spy Plus, that has inside another window, Windows 1. Both have the title bar menu, both have icons, both have title bar text, title bar context menu, there's only in Spy Plus, but still we can maximize the embedded window. You can go click on the icon and then maximize. And now you have the controls of the embedded window in here: minimize, restore, close, in the title bar of the Spy++ application. Okay, and this says that there's a window with caption project 1. And with this type project 1, let's see what that thing is. So there's project 1, all uppercase, and a struct. I don't like the fact that I need to scroll left, right, so let's fix that thing. Tools, options, wrap, and text editor general says that there's a setting for word wrap. Language is default, word wrap. Okay, that should be it. Now there's no more left, right scroll bars. So there's a project 1 that is an integer and is probably this guy. Class name. Find all references. F4. Here is the definition of SZ window class. So this is a string, a const wchrt pointer. SZ means string, and then Z means zero terminated. All strings are C programming language strings are null terminated. And then window class. We're pressing F4 to advance in the SZ window class references entire solution tool window. So this is the definition, declaration, line 13. And then we read from this variable at line 33. We read from the variable at line 81. And we also read from the variable at create window. We actually write to the variable SZ window class because we can see LPW string and a integer. So this is one of the ways of, in the C programming language, of passing an output or whatever ref string variable. So you pass not a const wchrt pointer, but a wchrt pointer, so buffer. You predefine the variable as an array of fixed dimensions, and then you pass the size as a parameter to the function. So the function will do a sprintf, but considering the size of the array which is passed through the second parameter, buffer max. So this actually writes to SZ window class, and we don't know what it writes there, so let's just run it. We should have put the breakpoint after the line. Let's find out. So it's project 1, all uppercase. And it might be this string. Okay, let's continue running. We'll need to I'm not sure how to do that. We'll need to use the search again because the view in Spy++, the tree view is stale. So select and OK. And it says that the tree view is very stale, so you'll need to refresh it. Click on the refresh button and then search again. Okay, so this is the window. Let's see how the graphical user interface part of Windows sees Windows. So a window is a native type for the Windows operating system graphical user interface. So for the window compositor, for the display server, for the display manager, whatever is called in Windows. In Linux, that would be a Wayland compositor or a X server tree of Windows. And very similar to the X Windows server, there's a ton of values which are related to a window. So a window is a basic type in the windowing in Windows. They come as a hierarchy. There's children and parents. And one window has a ton of properties which might be changed at runtime and which can be queried. There's, as we saw, state, if it's minimized, maximized, or restored. There's a top left, there's a bottom right, there's a width, there's a height, there's a font family, background color, foreground color, label, a ton of things which are specific to this very basic item, which is a window in Windows. There's a class name. There's a callback that's responsible to this window. Type of mouse cursor. The background color. It's visible. Has a minimized box, has a maximized box. Has a thick frame. Has a main menu. Has text. So this would be, capabilities. Project 1 is the label, whatever, the caption of the window, and that's used in this case because this is a actual window, not a label or a combo box or anything. It's being displayed in the title bar as the text of the title. The size of the window. And there's many other things which are actually in here and which you can maybe you can assign arbitrary tags to windows. Says which process has created the window, this process ID. Says which thread is the main thread, the thread that handles the main loop and painting for that process. This is actually the thread 1 in this process. It's in hexadecimals. This is an issue in my opinion. Process ID should always be displayed in integers because that's the way you display it in Task Manager. Right, you display it in decimals, base 10, so do also display it in base 10 in SPY++, property inspector, tab process, at the label process ID. Okay, let's see if there's children in here. I have opened the About box. I'm searching the button OK. It says that the tree of Windows is stale, which is true. Okay, and the About Project 1 is a window, but it's at the same top level as Microsoft SPY+. So this window and this window are at the same, have the same parent. The About box is not child of Project 1. They're actually siblings, About Project 1 and Project 1, which is not intuitive. Why would a child window of this window not be a child window of this window? Not be shown in the tree of windows that you can inspect at runtime using SPY++. But that might be a coding bug. Okay, so there's About Project, which is a window. There's a OK, which is also a window, but it's also a button. Let's see how buttons are different from windows. So they still have top left, bottom right, height, width. The buttons also have text, so in this case, OK, the caption. Style says that it's a BS, which is a button. The child window. The tree view of Windows. So the button is a child of About Project 1 and has a sibling in tab order. The previous one is this one, copyright C 2025. So this line is probably a standalone, this one with copyright 2025 is a standalone label and comes in order before the button. And I have clicked on the copyright 2025. So now the property inspector is inspected that window. And we can see that it's a different window, a different label and a different window. The label that says Project 1 version 1.0. Because we can see it's in previous window. And we can go there if we want. Okay, and there's probably also an icon somewhere or an image. So it's we're now with property inspector placed on a window that's child of About Project 1. That's before Project 1 version 1.0 and has the style SS icon. So it's a graphical user interface widget of type icon image. And it's probably showing a file with extension ICO, which we should have as a resource in our project. Resource files project1.ico is a Windows style ICO with the extension PNG. So ICOs are BMP files, which are a Windows standard way of representing bitmaps, so images. But the top left pixel is magic in the sense that that color represents transparency. So this green thing will be displayed as transparent everywhere. Takes the color of the top left pixel, it's this green thing, so this green becomes transparent. Okay, and the icons are 16 by 16 pixel 32-bit, which is great, 32 by 32 32-bit, and then larger and larger, and then at some point the format switches from BMP, which is Windows standard, existed in Windows 16, in Windows 3.11 for workgroups, switches to PNG, which is an open source format and was added to ICO files just, I know, somewhere in Windows XP at the end of the life, or maybe in Windows 6 or 7, Windows Vista. But this is because PNG BMP files of size 256 by 256 would make the ICO file too large. And then there's also support for 8 bits of color. 32 bits of color means RGBA, red, green, blue, and transparency, 8 bits each. So 255, 255, 255, 255, 4 times. Whereas 8-bit means that you have this palette. So no color is available except these colors. Gradients of gray, so we have just 8 colors possible in total, but you could define what each of those colors are. It's not, you're not forced to just use or ignore. I don't really know what 8-bit means, but from this suggestion, I guess that it's just 8 colors in 8-bit colors. Just, no, ignore. Okay, so this file is an ICO file, is used in the RC file in the resource of types icon IDI small and IDI project 1, so it's used twice. In here. RC file is a plain text file, but it's not using any of the newer plain text file formats. It's not an XML, it's not a JSON, it's not an YAML, not an INI also. Okay, and we can also see those resources compiled if we rename the executable. This is the executable project1.exe. We make a copy of it, change the extension to .res, and we double click on it. It should open in Visual Studio. And this is what the executable has inside it. There's a resource table, and then there's a string table with project 1 and project 1 different capitalizations. There's a Windows XP style manifest that says that running elevated as administrator is not required. There's a main menu that looks like this. So probably menus are also defined in .rc files. Let's see how we get there. Right-click on the RC file and view code. And we want help. Here it is, the main menu structure. There's file with accelerator F, help with accelerator H, exit with accelerator X, and about with accelerator A. We don't need the breakpoints any longer. Continue. Accelerators work like this. The F10 key shows the accelerators. You press the F10 key multiple times, it's going to hide them. So show the accelerator, then press F, then press X. Start the application, press Alt, but keep it pressed. The file element is selected when you press Alt, and then you can press Enter. And then you can press up and you can press right. So you can navigate the main menu using the arrow keys and Enter if you press the Alt keyboard key once. Like this. Okay, and even you can even navigate to the window title bar context menu. That's interesting. Or you can go Alt F, Alt H, Alt X, no, Alt F and then Alt X. It doesn't work, just the top level ones. And then just X without Alt pressed. Yes, so this should be it. This should be a run through very fast how to program for Windows using the classical MS v C++ compiler using Visual Studio, the latest version 2026, but using extremely classic technologies, Win32, MFC, ATL, resources, RC files, ICO files with PNG or BMP in them, the graphical user interface main loop, the SPY++ tool that actually shows the existing windows, which are Windows in the sense of the Windows operating system basic building block for graphical user interfaces, not just, so this is a window, but then this edit box is also a window. Windows, the word Windows is very overloaded in the Windows operating system. There's the operating system, Windows, and then there's two things that we can see on the screen, like window 1, window 2 are two windows, right? But then there's also this concept that an atom of the graphical user interface is also called a window. So this thing, the OK button, is actually a window. You can inspect the windows at runtime, you can modify them, you can send messages to them. So you can hide them, maximize them, change their top, change their left, right, bottom, size, width, change their background color, read everything, all of the properties of a window, such as you can read the text inside that's displayed on a button, the foreground color, etc. We have also created command line applications such that we can increment our knowledge. We have first started with a standard C++ command line hello world application. We have progressed to a minimal Windows style with MFC and precompiled header command line application, and then to a minimal Windows graphical user interface application that actually shows a window, a main menu, and a help about dialog that also uses minimal amounts of code, doesn't really depend on MFC, is not really C++, is C programming language, and it's using very low-level building blocks for Win32 graphical user interface applications such as the WM Paint, window messages, main loops, case switches. It's handling accelerators manually straight in C programming language source code. So this is it. Thank you.